Okay, this is functions number 1, one-to-one and onto functions. Okay, we're considering two functions. F of x is equal to 2x and g of x is equal to x squared. We're going to input the domain of -2, 0, and 2 into each function. So we'll store first -2, and our output value for -2 is going to be -4. We're going to store 0. Output value is going to be 0 for 2x. And for 2, output value is going to be 4. Let's do the same thing for g at x, which is x squared. So if we input -2, so we'll store -2, output's going to be +4. We input 0, output value is going to be 0. If we input +2, output value is going to be 4. So all this we could do by substitution or using store. What is fundamentally different between these two functions in terms of how the elements of this domain get mapped into the elements of the range? So the first one, f at x, has no y repeats, and g of x has y repeats. So f of x has no y repeats, and g of x has y repeats. So in a one-to-one function, there are no y repeats. So f of x1 will not equal f of x2. So it's a function, so no x repeats, and it's a one-to-one function when no y values repeat. So in a one-to-one function, in other words, different inputs give different outputs. In example number 1, it is not a function because there are x values that repeat. So it cannot be a one-to-one function if it's not a function to begin with. Number 2 is a function, but because we've got y values that repeat, it is not a one-to-one function. Number 3 is a function because no x values nor no y values repeat. Number 4 is not a function because these two x values repeat. So if it's not a function, it cannot be a one-to-one function. If we were to circle the two graphs above that are functions, that means they've got to pass the vertical line test. So that'll be number 1, which passes the vertical line test, and number 4, which also passes the vertical line test. So they both pass the vertical line test. Of those two, number 1 does not pass the horizontal line test. So if I make a horizontal line, it crosses more than one point. Yet in number 4, it also passes the horizontal line test. So number 4 passes the horizontal line test. So the horizontal line test is performed to determine if it is a one-to-one function. So which of the following represents the graph of a one-to-one function? Well, first of all, it's got to be a function. So 1 is not a function because it doesn't pass the vertical line test. 2 is a function, but it is not a one-to-one because it doesn't pass the horizontal line test. 4 passes the vertical, but does not pass the horizontal. Number 3 passes both vertical and horizontal line test. Okay, if we go to y1, let's sketch the function, the absolute value of x minus 5. So if you go to y1, go to alpha window number 1, you'll see ABS, which means absolute value. And then do zoom 6, and let's make a sketch of this. And we see it's not a one-to-one function because it doesn't pass the horizontal line test. Or you can go to your table and see that your y values do repeat. Onto functions. An onto function, the function from set A to set B is onto if the range of the function is equal to set B. A function is onto if each element of the range corresponds to an element of the domain. So if we're using the function f of n is equal to 2n plus 1, if n is equal to 1, f of 1 is going to be equal to 3. F of 2, we store 2, it's going to equal 5. F of 3 is going to equal 7. So one more time, f of 1 is going to equal 3. F of 2 is equal to 5. F of 3 is equal to 7. It is not a one-to-one because, it is not an onto because not all range values were the result of mapping. We have a value of 6 and 4 that were not the result of the mapping, so it's not an onto function. So of the 4 functions shown below, which is an onto mapping from the set of real numbers to the set of real numbers? So we are going from reals to reals. The best way to show this is to use a sketch. So if we put y1 in our calculator and make a quick sketch, our domain is all reals, but our range is 0 to infinity, so it's not onto. If we put y1, the second equation, absolute value of x minus 4, we see again that our domain is all reals, but our range is from -4 to infinity, and the condition was it goes from real to real. If we put number 3 in our y1, which is our graphing calculator, 5x minus 2. We get the graph of a line. And our domain is all real numbers, as well as our range. So we go from reals to reals. Our answer is number 3. Number 4, our domain is going to be all reals, but our range is going to be only 8.